On September 15, 2017, at 7:55 in the morning Eastern Time, a spacecraft traveling at 111,000 kilometers per hour entered Saturn's atmosphere and was destroyed. It burned up in roughly 30 seconds. By the time NASA's signal confirming the final transmission arrived at Earth, a 83-minute delay at that distance, the spacecraft had already been gone for over an hour. The spacecraft was Cassini. It had been orbiting Saturn for 13 years, and in its final 5 months, it did something no machine had ever done. It flew between Saturn and its rings, threading a gap 2,000 kilometers wide 22 times to take the first measurements ever made from inside that space. What it found there changed what we think Saturn is. Cassini launched in October 1997. It took 7 years to reach Saturn, using gravity assists from Venus twice, then Earth, then Jupiter to build up enough speed. When it arrived in 2004, it became only the second spacecraft to orbit Saturn. Pioneer 11 and the 2 Voyagers had flown past in the 1970s and early 1980s, but none had stayed. Cassini stayed for 13 years. It orbited Saturn 294 times. It discovered 6 new moons. It watched storms erupt across the planet's northern hemisphere that were larger than the entire Earth. It found lightning in Saturn's atmosphere discharging with 10,000 times the energy of a typical Earth thunderstorm. It caught active geysers erupting from Enceladus, Saturn's 6th largest moon, venting water vapor and organic compounds into space from an ocean locked under 30 to 40 kilometers of ice. And it dropped a separate probe, Huygens, built by the European Space Agency, onto the surface of Titan in January 2005. Huygens descended through Titan's thick orange atmosphere for 2 hours and 27 minutes, transmitting data the whole way, before landing on a surface that looked like wet sand, but was made of hydrocarbon granules. It was the most distant soft landing ever achieved by any spacecraft at the time. By 2017, Cassini was running low on propellant. Without enough fuel to maneuver, the spacecraft would eventually drift and contaminate either Titan or Enceladus, both potential hosts for microbial life. NASA couldn't risk that. So they decided to use the last of the fuel deliberately, to send Cassini where no spacecraft had ever gone. The grand finale began in April 2017. Engineers threaded Cassini through the gap between Saturn's innermost ring, the D ring, and the top of Saturn's cloud layer. The gap is roughly 2,000 kilometers wide, which sounds large until you consider that Cassini was traveling at 111,000 kilometers per hour. At that speed, even a centimeter-sized particle would be catastrophic. The team had to calculate the density of that gap from Voyager flyby data taken 35 years earlier and make their best estimate about whether anything would hit the spacecraft. The first dive, on April 26, 2017, Cassini turned its main dish toward oncoming particles to use it as a shield. It survived. The gap turned out to be largely empty. Over the following 5 months, Cassini made 22 passes through it. Each pass produced data that had never existed before. The instruments measured the composition of the material in the gap directly. They measured Saturn's gravitational field with enough precision to map density variations inside the planet. They detected electric currents flowing between the rings and the planet itself. And the ion and neutral mass spectrometer sampled the air, if you can call it that, at the very top of Saturn's atmosphere, at an altitude where the rings and the planet are almost touching. What came back was not what anyone expected. The gap between the rings and Saturn is not empty. It's filled with a constant rain of material, mostly water, but also methane, propane, butane, carbon dioxide, nitrogen, and complex organic compounds. The rings are draining into Saturn. The mass flow rate measured by Cassini? between 4,800 and 44,000 kilograms per second. Every second. The entire mass of the rings, roughly half the mass of the moon Mimas, is being lost to Saturn's atmosphere at a rate that implies the rings have existed for no more than a few 100 million years. Saturn is 4.5 billion years old. Its rings might be 100 million years old. When the dinosaurs appeared on Earth, Saturn's rings may not have existed yet. The final plunge on September 15, 2017, lasted about 30 seconds before the spacecraft was destroyed. But in those 30 seconds, and in the atmospheric passes that preceded it, Cassini's instruments returned data that planetary scientists are still working through. The atmosphere at the level where Cassini entered is about 4% helium by volume. That matters because Saturn radiates more heat than it receives from the Sun, a long-standing puzzle. One explanation is that helium, being denser than hydrogen, rains down toward the core, releasing gravitational energy as heat. The 4% measurement near the upper atmosphere fits with models of helium depletion at depth, which would support the helium rain hypothesis. Saturn's magnetic field was another surprise. Every other magnetized planet in the solar system has a magnetic axis that's slightly tilted relative to its rotation axis. Earth's is about 11 degrees off. Saturn's tilt, as measured by Cassini in the grand finale passes, is less than 0.01 degrees, essentially perfect alignment. That's almost impossible to explain with any current theory of magnetic field generation. A tilted axis is what allows scientists to detect how fast a planet rotates by watching magnetic pulsations. With Saturn's axis perpendicular to the equator, the rotation rate of the deep interior is still not definitively known. Inside the rings themselves, Cassini found a new radiation belt, a band of high-energy particles trapped between the D ring and the planet that had never been detected before because no spacecraft had ever been in that location to measure it. Saturn is not a destination, not in any near-term sense. It's a gas giant with no surface to stand on and atmospheric pressures that would crush any structure we currently know how to build. The relevant question for anyone thinking about long-term human presence in the outer solar system is not Saturn itself, but the system around it. Titan is the standout. It's the only moon in the solar system with a thick atmosphere, the only place beyond Earth where liquid exists on the surface in stable bodies. The lakes are not water. They're liquid methane and ethane at temperatures around -179 Celsius. But the chemistry happening in Titan's atmosphere is the most complex prebiotic chemistry in the solar system. Organic molecules, some of which are not found naturally on Earth, form continuously in the haze layer and rain down onto the surface. Cassini detected over 100 distinct organic compounds in Titan's atmosphere. NASA's Dragonfly mission launches in 2028 and arrives at Titan in 2034. It's a nuclear-powered quadcopter, a rotorcraft, that will fly between landing sites on Titan's surface, sampling the chemistry and searching for biosignatures. It will cover more ground than all previous planetary rovers combined. Titan's thick atmosphere and low gravity make flight easier there than on Mars. Enceladus is the other candidate. Cassini flew through its geysers 23 times and found water vapor, molecular hydrogen, silica nanoparticles, carbon dioxide, and organic compounds, including amino acid precursors. The hydrogen is particularly significant. It's the signature of ongoing hydrothermal reactions between hot rock and water, which on Earth is the chemistry that sustains deep-sea vent ecosystems. No sunlight required, just heat and chemistry. There is no Saturn orbiter currently in development to replace Cassini. The next mission to the Saturn system is Dragonfly, going to Titan, launching in 2028. ESA has proposed a dedicated Enceladus mission that could launch in the early 2040s and arrive a decade later. The gap between Cassini's final transmission and the next spacecraft reaching Saturn will be at least 17 years. Every data point we have about Saturn's interior, rings, magnetic field, and moons comes from a mission that ended in 2017. And that data is still yielding discoveries. Papers analyzing Cassini's grand finale measurements were published as recently as 2025 and 2026, nearly a decade after the spacecraft was gone. The rings are disappearing. The current rate of mass loss, confirmed by Cassini's direct measurements, gives the rings a remaining lifetime of 15 million to 400 million years. In geological terms, they may be a temporary feature of the solar system. Anyone born in the far future, if the word future means anything on those timescales, will look at Saturn and see a gas giant without rings. We are alive at the moment the rings exist. That's worth noting. The question of why the rings exist at all, when they formed, and whether the process that created them might repeat, are all open. The best candidate for their origin is a collision or tidal disruption of a large moon, perhaps 100 to 400 million years ago, that scattered ice across Saturn's orbital plane. The debris hasn't finished falling in yet. It's doing it now, at thousands of kilograms per second, measured by a spacecraft that burned up in the process of taking the measurement. Cassini was active at Saturn for 13 years and 76 days. It orbited 294 times, returned over 450,000 images, and generated 635 gigabytes of science data. The team that operated it had worked on the mission, in some cases, for over 2 decades. When the final signal came through, the carrier wave, not even data, just presence, and then stopped, the mission controllers in Pasadena knew it was over, because the silence was instantaneous. A spacecraft that size, at that altitude, moving at that speed, doesn't slowly go quiet. What Cassini found inside Saturn was exactly what science is supposed to find. Not confirmation, but complication. A magnetic field too perfect to explain. Rings too young to have been there for the history of the solar system. An atmosphere receiving tons of organic material every second from the rings above it. A gravity field revealing a structured interior no one had predicted. The spacecraft is gone. The data isn't. And the Saturn system, if anything, is more interesting now than it was before Cassini arrived.